Hello and welcome to today's lecture on Internet and Internetworking. Here is the outline of today's lecture. After a brief introduction, I shall discuss about why Internetworking, why at all Internetworking is needed. Then I shall discuss various issues related to Internetworking. And then you will see that it will involve two types of devices, two types of components. One is hardware, another is software. And in this lecture I shall focus on the hardware components, which are essentially Internetworking devices. And there exist various types of devices such as repeater, hub, bridge of different kinds, like there is some bridge which does forwarding and learning, which are known as transparent bridge, then source routing bridge, and then there are switches, routers and gateways. So I shall discuss all of them one after the other. And on completion, the student will be able to specify the need for Internetworking. They will be able to state various issues related to Internetworking, and they will be able to explain the operation of various Internetworking devices like hubs, bridges, then transparents and source routing bridges. These transparent bridges uses bridge forwarding and routing, how it does it, and they will be able to also explain the switches, routers and gateways. Let us look at the possible communication approaches. We have discussed different types of communication systems in the last 32 lectures, and in these 32 lectures we have discussed various communication approaches. First one is point to point. We have seen how two stations can communicate with each other with the help of point to point links such as RS-232C. Then we have discussed different types of switched communication network, which is also known as, essentially these are WANs, wide area networks, for example telephone network, then X.25, frame relay and so on. So these are essentially switched communication networks. We have also discussed multi-point broadcast networks like LAN, and then satellite networks, then your cellular telephone networks. These are essentially multi-point broadcast networks. So these are the three possible communication approaches we have already discussed in details. Now you will find that but the LAN technologies are designed to provide high speed communication over a small geographical area. So if you look at each of them separately, you will find that the function of LAN is very limited over a small geographical region. On the other hand, WAN technologies are designed to provide communication across different cities, countries and continents, but their rate of data transfer is not very high. And it has been observed that isolated LAN and WAN have limited potential and usefulness. So unless these LANs and WANs are interconnected together, they are able to exchange information with one another, these isolated LANs and WANs are of not much use. This has led to what is known as Internetworking. And Internet. So what is Internet? So basic objective is to connect individual heterogeneous networks of both LAN and WAN distributed across the world using suitable hardware and software in such a way that it gives the user the illusion of a single network. So far as the user is concerned, it will be communicating through a number of systems, LANs, WANs, but it will be transparent to them. They will be able to communicate seamlessly, and that is the objective of Internet. And this single virtual network is widely known as Internet, which is essentially a network of networks. As you can see in this diagram, we have several LANs, LAN 1, LAN 2, and a number of WANs, wide area networks, WAN 1, WAN 2, and LAN 3. You see several LANs and WANs are interconnected together, and this forms the Internet. And here are the users or stations connected to different LANs and WANs. To them, this within the whatever is within this this circle is transparent. That means they can communicate with each other irrespective of whether it is passing through this LAN, then through this WAN and reaching this station, or this particular station is communicating through WAN 2, LAN 3, then LAN 2, and it is communicating. So this will be transparent to it. That is the objective of Internet, and the way it is being done is known as Internetworking. So let us have a look at the various requirements for Internetworking. First objective, as I have stated, to provide link between networks. You have got isolated networks, LANs, WANs, you would like to link them together and link between these networks. To provide a route for delivery of data between processes on different networks. That means processes running on different networks, they have to be, that has to be provided a route so that from one network it can be transferred or delivered in another network. Moreover, the another requirement is to provide an accounting service that keeps track of the use of various networks. That means a particular network may be using 2 LANs and a wide area networks, and for some of them one has to pay, and so some accounting is necessary, and routers, and also to maintain status information. So apart from keeping track of what is going on, some status information is maintained so that the users or stations can know what is going on. If there is any wrong, they can get the information. Then another requirement is to accommodate a number of differences among the networks. So whenever you interconnect a number of LANs and WANs of heterogeneous type, it is quite natural they will be having many differences. Let us see what are the possible differences exist. First one is addressing schemes. So we know that for local area network we have discussed the addressing scheme. The Ethernet LAN uses 48-bit MAC address, but in other networks it can be different. We have already discussed the token ring and token bus networks. Their addresses are not same as the Ethernet. So the addressing scheme may be different in different networks, in different LANs and WANs. Then comes the packet size. The packet size of different networks can be different. In one case it can be 15,000 bytes, in another case it can be 64 kilobytes, and like that. So the packet size can vary from network to network. Then the network access mechanism. We have discussed various medium access control techniques, and we have seen the medium access control techniques used in different networks are indeed different. So you have to resolve, you have to in spite of these differences, communication should be possible. Then timeouts. Timeouts means as the packet passes through the network, it is not allowed to pass, stay in the network for a very long time. Some timeout is maintained. So that timeout, those times may be different in different networks. Then error recovery. We have seen that a particular packet, whenever it is passing through a network or a number of networks, there is a possibility of error. So whenever an error occurs, you have to recover from the error situation. That is your error recovery, and that can be different in different networks. Then status reporting also can be different in different networks. Routing techniques, we have discussed various routing techniques like fixed routing, then your adaptive routing and so on. That routing approaches can be different in different networks. Then user access control can be also different in different networks. Then it can be connection oriented or datagram type of service. So services can be different. So in spite of all these differences, in the internet, it is the objective is to communicate from between two stations in a transparent manner, and obviously the objective of internet working is to accommodate all these differences. Now let us have a look at the various internet working issues. First one is addressing. We have seen that whenever two stations wants to communicate with each other, they must have some address. And in case of Ethernet, we have seen that 48-bit medium access control, MAC address. However, in other networks, that addressing scheme can be different. So addressing we have to discuss. Then we have to do packetizing. Those packets had to, apart from the data, other information like source address, destination address, and various other things had to be put together in the form of a frame, and that is packetizing. Then, as we have seen, the packet size that can pass through a network cannot be same. So it may be necessary to divide a particular packet into a number of packets as it goes through a network. Then at the other end or in the destination node, they have to be put together. They have to be reassembled. So it will be necessary to perform fragmentation and reassembly. Then, as I have told, you have to do the routing as the packet passes through a sequence of networks. Then, for the purpose of reliability, it will be necessary to do flow control, error detection and error control. It will be also necessary to perform congestion control and to ensure quality of service. Then other issues like security. Network security has to be maintained as the data passes through the network. Security has to be maintained with the help of suitable encryption technique, encryption decryption technique. Then it will be sometimes it is necessary to use names instead of address, because it is difficult to memorize or remember the names. So sometimes it will be necessary to use address, and then we have to see how the naming is being done and how actually mapping from name to address is performed. So these are the various internetworking issues we have to discuss, and first we shall focus on the various types of hardware and software needed for this purpose. You will see that we have to use different types of hardware such as repeaters and hubs, which are essentially, these are layer 1 relay. They act as some kind of relay. Then bridge and switches, they are layer 2 relay. Then router, which are layer 3 relay, and gateway, which can operate in all the layers, which is layer 7 relay. So these are the different hardware components we have to use when we do internet working. On the other hand, you will require a software, which the most common software that is used today is TCP/IP, Transmission Control Protocol and Internet Protocol. It operates in 2 layers. You will see there are 4 layers, but TCP/IP essentially operates in 2 layers, and TCP in the transport layer, IP in the network layer, and it provides it's a protocol suite for internetworking. So this TCP/IP acts some kind of glue, acts as glue, and which binds all different types of networks into one. So TCP/IP is a software which acts as a glue and which actually puts different networks together into one network. And of course, there are application layer protocols which operates on top of TCP/IP like Telnet, FTP, SMTP. We shall discuss about them later on. So, we will require some hardware and some software. In this lecture, we shall mainly focus on hardware, and in the next two lectures, we shall focus on TCP/IP. So, first let us consider repeater. A repeater connects different segments of a LAN. We have seen that there is a maximum length of a segment of network. For example, if you are considering Ethernet, then we know the maximum segment length of the Ethernet, that 802.3 Ethernet, is 500 meter. But if you want to have a network, a single network with network span more than 500 meter, then you have to use a device known as a repeater in between two segments. So, here we see you have got two segments, each of them can be 500 meter, this is 500 meter and this is 500 meter. So, if you put them together, you get a 1 kilometer of Ethernet LAN. And as you can see, these two segments are linked by a device known as repeater. So, what the repeater does? It forwards every frame it receives. So, if it receives a frame on this segment, it forwards it to segment 2. If it receives a frame on this segment, it forwards it to segment 1. So, in this way it does the forwarding. You may be asking, is it a amplifier, or in what way it differs from amplifier? Actually, a repeater is not really an amplifier. What an amplifier does, it amplifies the signal as well as the noise. It does not discriminate between signal and noise. On the other hand, a repeater essentially extracts the signal, removes the noise and regenerates the signal. That means, if you are sending a sequence of zeros and ones on this side, then it may get submerged in noise, but it will remove the noise and extract these bit sequences and then regenerate it, bring the voltage levels corresponding to 0 and 1 and put them on the other side. So, this way it is not really an amplifier, but it is a regenerator. That means, on this side the noises are not transferred. If you are sending from this side to this side, the noises are not transferred, but bit sequences are transferred in regenerated form. So, it is a bidirectional link. The transfer of bits can take place from this side to this side, as well as from the other side to this side, segment 1 to segment 2 and segment 2 to segment 1. So, a repeater is a very useful device for expanding a LAN. So, you are not really connecting two LANs by repeater, but essentially you are increasing the span of a local area network. As you know, in case of Ethernet, you can have 5 repeaters at most in cascade. So, in that way the maximum network span can be 2.5 kilometer. So, you will require a sequence of repeaters. So, before the signal level becomes very poor, becomes very difficult to extract from noise, you have to put repeater. So, the repeaters are very useful device for increasing the size of networks. Now, another version of repeater, which is not really which is usually called hubs. Hub is a generic term, but hub is a generic term from where signals originate, signals is generated and received. But here by hub we commonly refer to a device known as multi-port repeater. Essentially it is a multi-port repeater. We have seen in the previous diagram, a repeater has got 2 ports. Here you have got 1 port, another you have got another port. So, it is linking 2 segments, but a hub can have multiple ports. So, can be used to create multiple levels of hierarchy. With the help of a hub, you can create a single LAN having multiple levels of hierarchy. And stations connect to the hub usually with the help of RJ45 connector, and as we have already discussed, maximum segment length is 100 meters. So, it is easy to maintain and diagnose, that means fault detection is easy. That is why this type of topology is becoming more and more popular. Here you see you have got a hub at the upper level. So, this is connected to 3 different ports. Here, although it is shown that it is connected to a single port, usually essentially a hub has got multiple ports. It has got multiple ports. So, this is a port, 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 this is a port. So, these 3 hubs are connected to 3 different ports here. Then in the second level, there are a number of stations or computers are connected to different ports of the hub. So, it is essentially a multi-port repeater, and you can see how in a hierarchical manner you can expand a network and create a big network with a large number of computers. Usually hubs are available with 8 ports, 16 ports, 24 ports, or nowadays 48 ports. Now, the second device that we shall discuss is bridges. A bridge operates both in physical and data link layer. We have seen in case of repeater, it does not do any filtering. Whatever is received on a port, say this is a hub, let us assume, and you have got say a number of ports, say 8 port is shown here. Whatever is on this port, the signal, same signal is available on all other ports. It is repeated on all ports. So, as a result, hub is some kind of dump device. It does not do any filtering except regeneration of the signal, and same signal is repeated on all other ports. So, it does not do any filtering or routing. On the other hand, a bridge uses a table for filtering and routing. That means, if a packet arrives here, a bridge will not forward it to all other ports, which is done by a hub. A hub forwards forward the packet on all the ports, but a bridge does not do that. So, and however, the bridge does not change the physical addresses in a frame. So, as we know, a frame will have the source address, destination address, then your data, then CRC. So, various parts will be there in a frame, and it does not change the content, but it does the filtering or routing. We may call it routing as well. And there are 2 types of bridges. One is known as transparent bridge, another is known as source routing bridges. Let us see the operation of these 2 types of bridges. So, here if the operation of a bridge is shown. Here, as you can see, these are the 48-bit MAC addresses represented in hex form is shown here. So, if the bridge in this particular case, a bridge is shown with 2 ports, but as I said, a bridge can have many ports. So, on this port 1, a LAN 1 is connected, to which 2 stations are connected with the MAC addresses given here. So, port 1 and address. So, the table is maintained, address and port number. On port 2, again 2 other stations are connected with these addresses 742B and so on, 742B and so on. This is 112, 113. So, this is connected to port 2. This kind of table is maintained in a bridge, and this table is used for the purpose of filtering, or you may call it routing. And this transparent bridge, what it does, the function of a transparent bridge is, the name transparent comes from this, is all stations are unaware of what is going on inside the bridge. It acts as some kind of plug and play device. A bridge is installed, there is no need to do any reconfiguration, any initialization, nothing is required. Simply plug it, and then it will start operating, and that table will be automatically created. So, reconfiguration of the bridge is not necessary, it can be added and removed without being noticed. And question arises how it really works, and so that it behaves like a transparent bridge. Actually, it performs two important functions. First function that it does is known as forwarding of frames. This is the key function it performs. Another operation that is known as learning, which is necessary for forwarding, is done. This learning is done to create the forwarding table, the table that I have shown just now. What is being performed in bridge forwarding? It essentially performs three functions. Discard the frame if source and destination addresses are same. That means if the source and destination addresses are same, that means are on the same port, or by same it means are, I should not say same, are on the same port. For example, we have seen that these two addresses are on the same port, connected to the same port. So, if a destination address is say if a frame is generated on this with destination address this or this on port 1, then what will happen, that particular packet, suppose this is sending a packet to this station, that means the bridge will discard that packet because it is directly communicated between this station to this station. So, it will not be forwarded to the other port of the bridge. Second operation that is done is forward the frame if the source and destination addresses are different and destination address is present in the table. That means we have seen that suppose the destination address corresponds to the other port, and if it is present here and the port number is known, it will simply forward it. Suppose this station is sending a frame with this destination address. So, this destination address is present in the table and it shows that it is on port number 2. So, this frame is forwarded on port number 2. So, this is how this works. So, this is the second operation, that is forwarding. So, forward the frame. First one was discard. Third is, you see, a particular destination address may not be present in the table. So, in the beginning the destination addresses, whenever you plug a bridge in the network, that table will be empty. So, in such a case that there will be no destination address. In such a case what the bridge does is it forwards on all the port except from where it has come. So, this is known as flooding. So, flooding is done and obviously it will be delivered to the source destination address. Now, for successful operation of the bridge forwarding, bridge learning process is performed. So, here as you can see, if a particular station sends a packet, when it sends it, that automatically that station's MAC address is recorded in the table along with the port number. So, source found in the forwarding database, if it is no, then that source address that it is added to the source database with direction and new timer. You see, it also maintains a timer. The reason for timer is that table is not really static. The table that is being created, it keeps on changing with time. The reason for that is, suppose a particular station does not send any packet for a long time. Station is off or something like that. In such a case, what will happen, after few minutes it will see the condition of the timer, and when the timeout occurs, that station's MAC address is removed from the table. And whenever a frame is received, then even when the frame MAC address is present in the database, its timer is updated. So its direction is updated. That means you can take out a station from one place. For example, here you can take out a station from here to there. Then automatically, whenever this station after it is connected to this side sends a frame, automatically that address will be, that table will be updated. So apart from performing the building up the table, it also maintains the timer, and whenever a timeout occurs, those addresses are removed from the table. So this is how bridge learning operation is performed. So bridge learning and bridge forwarding together makes the transparent bridge operation. And here it is shown how the bridge forwarding table is created. So this is the initial condition. A bridge has been installed, plugged in, and as you can see, it is connected to 4 LANs. This is LAN 1, this is LAN 2, this is LAN 3, and this is LAN 4. So it is connected to 4 LANs. Initially, this table is empty. Now, whenever A sends a packet, the bridge notices it and then builds up this table. Whenever C sends a packet, it also notices it and builds up the table. Here I have written A and C. Essentially, you have to write the MAC addresses, 48-bit MAC addresses if it is Ethernet. So in this way, in the long run, all the stations, if they are active, their entries will come in the address table along with the port number. So here, after all the stations have sent a frame, this will be the situation of the table. I have not shown the timer here. The timer value is also maintained, and whenever suppose this C is turned off, then automatically after some time this entry will be removed from the table. So this is how the bridge forwarding table is created in transparent bridge operation. Now, this forwarding and learning processes work fine as long as there is no redundant bridge in the system. So only there exists one path from one station to the another. In such a case, there is no problem. So for unique path, it is necessary that there is no redundant bridge. So from one station to another station, there is a unique path, maybe through a number of bridges. So these are the bridges. This is another one bridge, this is another bridge, this is a station, this is a station. However, from the viewpoint of reliability, it is necessary to have multiple paths. The reason is, if one path, say one bridge, becomes faulty, then the source stations will not be able to send if there is no redundant path. So for the sake of reliability, it is necessary to have redundancy. Now, to get best of both the worlds, that means the advantage of this transparent bridge, at the same time to avoid the problem of redundancy, which is essentially redundancy creates loop problem. So this loop problem we have to avoid, and if we want to retain redundancy, and let us see how it really works, how the loop problem arises. So here you can see there are 2 LANs. This is LAN X and LAN Y, and these are connected by 2 bridges, bridge A and bridge B. Whenever stations A sends a frame to bridge A and sends a frame on this network LAN X, then bridge A as well as bridge B receives it, and since the destination address is not known, it sends it to network LAN Y, and also bridge A sends it to LAN Y. Now this T1, this is received by bridge B, and since again it forwards it to LAN X. So in this way, some kind of loop occurs. So a frame sent by station A goes to bridge B, goes to LAN Y, then it is forwarded by bridge A, again it is forwarded by bridge B. So in this way looping arises. So a frame can indefinitely keep on looping in the two networks before being delivered. This is the typical loop problem, and we have to avoid that loop problem. So loop problem can be avoided by using a technique known as spanning tree. So spanning tree is essentially a special kind of graph where there is no loop. So a spanning tree topology is created. The methodology for setting up a spanning tree is known as spanning tree algorithm. There exist standard algorithms, efficient algorithms for creating spanning tree of a graph, and we can use that for transparent bridge and without changing the physical topology. So some kind of logical topology is created that overlays on the physical one. Let us see how exactly it is being done here. So here you see you have got LAN 1 to which 2 bridges are connected, you have got LAN 2 to which 1 bridge is connected, you have got LAN 3 to which 3 bridges are connected, and then LAN 4 and LAN 5 there is a 1 bridge connected. So in this way you can see you have got multiple paths and multiple bridges in this network, which is connecting 5 different LANs. Now there is a spanning tree algorithm which identifies a root bridge, then it identifies a destination bridge, and it identifies a forwarding port, and identifies a blocking port. I am not discussing the algorithm which makes use these terminologies, but the outcome is shown here. For example, this is the root bridge for LAN 1. Actually, if you have multiple bridges and the bridge having lower MAC address is used as the root bridge. So this is considered as the root bridge, and then you can see here this particular path, this particular path is blocking path. On the other hand, this bridge B1 is used, both the ports are forwarding ports. And then if you look at this bridge, you can see this is the forwarding port, and this is the blocking port. So the dotted lines are blocking ports. That means these links are not used for forwarding purposes. And whenever you do this, then you find from any LAN to any LAN there is a unique path. For example, say from LAN 1, if you want to go to LAN 2, you have to go only through this bridge B1, and from say LAN 2 to LAN 3, if you want to go, you have to use the bridge 7, then from bridge 7 it goes to bridge 1, then to bridge 2, then through bridge 1 it goes to LAN 3, or say bridge 1 wants to this LAN 2 wants to communicate to some stations on LAN 5, let us assume. So although there is a path like this, instead of this path, as you can see, it has to be connected, the forwarding will take place in this manner, and the path is unique. So there is a unique path, and say logical topology is created on this physical topology, and dotted lines are not used for forwarding purposes, they are blocked. That is the spanning tree approach. However, if because of some reason, suppose this particular bridge becomes faulty, then automatically the spanning tree will be modified, and some of these ports will become forwarding port, and this bridge will be both the ports will become the blocking ports. So in this way, spanning tree is being created, and using the spanning tree the transparent bridge will work. Of course, there are apart from this transparent bridges, there is another routing technique that is used, which is known as source routing. In this source routing, the source itself decides the route that will be used by a packet through a number of bridges. So all the intermediate bridge addresses are provided by the source node, source station. So the packet format is shown here. As we have seen, normally the destination and address and source addresses are provided. But in this particular frame, as you can see, apart from destination address and source address, the routing information contains a number of other addresses. For example, route number 1 designator, route number 2 designator, route number M designator. With the help of these designators, you can identify the route, and also there are some bits, 16 bits are there for route control. I am not discussing in detail, but you see the source station provides all the information for routing and through which bridges it will the packet should go one after the other, and that all the information is provided. So it is quite simple. However, the source node has to gather information from other parts of the network before this packet can be framed, and it can send a packet to a destination station. Now coming to switches, we have seen the function of a bridge. What is a switch? A switch is nothing but a fast bridge. We have seen a bridge performs the forwarding operation or routing function. Maybe it can be done by software, then it will be quite slow. Instead of doing by software, it can be done by hardware, and it can be done very fast, and that is what is precisely done in switches. And it uses the same technique. It uses a table or a directory having the address and port number, and each frame is forwarded after examining the address and forwarded to the proper port number. And I have already discussed about the three techniques: cut through, collision free, and fully buffered. So this cut through of for the routing is done only whenever a frame is received, and only after receiving the destination address, which is in the beginning of the frame is transferred. On the other hand, to make a frame collision free, particularly in the context of Ethernet, you have to receive at least 64 bytes. So after receiving 64 bytes, and if there is no collision, then a frame is forwarded. Then we say that the frame is collision free, but error detection is not performed. To perform error detection, you have to receive the entire frame, compute the CRC, and after receiving the entire frame and computation of CRC, if it is found to be error free, then it is forwarded in the third case, which forwards a collision and error free frames. So these are the three approaches are used. Obviously, the cut through approach has the smallest delay, but it does not do it suffers from these disadvantages. It does not do collision detection and error detection. A frame can be forwarded which has suffered collision and which is not error free. Collision free has got medium delay. Also you have got a number of output ports. So this is the schematic diagram of a router, and which performs the routing of packets in layer 3. As you have seen, a router has got 4 basic components: input port, it performs physical and data link layer functions of the router. The ports are also provided with buffer to hold the packet before forwarding the to the switching fabric. Output ports perform the same functions as the input ports, but it does it in the reverse order. The routing processors perform the function of the network layer. The process involves table lookup, as you have already seen, and the switching fabric moves the packet from the input queue to the output queue by using specialized mechanism. And this is the two different functions shown here. So here the input port receives from packet from the physical layer processor, and then it does the data link layer processing. There is a data link layer processor, then it maintains a queue before it can be transmitted. Similarly, whenever a packet goes to the output, a queue is maintained, then data link layer processor does the processing, then it goes to the physical layer processor before it is launched on the physical transmission media. And here is the switching fabric, typical switching fabric that is used. We have already discussed about it, so I am not discussing about it in detail here. So this is a special piece of hardware which moves the packet from input to the output very quickly. So here a simple internet is shown, where, as you can see, you have got a ring LAN, a switched wide area network, a local area network, bus type local area network. There are two point-to-point links between two WANs, wide area networks, and here you have got another LAN. And you will notice that here, whenever the internet working is being done, we have given a different kind of notation, 240.34.8.24. What are these? We have not yet discussed. These are essentially IP addresses that is being used in the internet working, and which is part of the TCP IP. So in the next lecture I shall discuss about the use of this type of addresses, these IP addresses, which is used when you do internet working and data is transferred from one LAN to another LAN through a wide area network or between two wide area network. Here is the summary of the what we have discussed today. We have discussed about 3 different pieces of hardware. One is your repeater or hubs, which operates in physical layer, or layer 1, which can be considered as layer 1 relay. Then we have discussed bridge, which operates in data link in layer 2, data link layer, which can be considered as data link relay or layer 2 relay. Then router, which is operates in network layer, so it can be considered as network relay or layer 3 relay. Another type of hardware which I have not discussed is known as layer 7 relay. This works above the network layer, such as application layer. This kind of gateway can be necessary. That means it will not only operate in layer 2 or layer 3. That means routing is not only performed based on the MAC address or IP address. It can check the contents of data, for example, the content of an email. That kind of application gateway may be necessary in implementing firewalls for the purpose of security. So although for normal routing purposes gateway is not necessary, but in special situations such as in implementing firewall for the purpose of security, this kind of device will be necessary, and which operates, as you can see, in layer 7. That means it operates in application layer. It can look at the contents of data. Then, as I said, the software, I have briefly mentioned about it, which acts as a glue to link different types of LAN and WAN to provide internet, a single integrated network for seamless communication. I shall discuss about the software in the next lecture, next 2 lectures in detail. and here it gives some kind of pictorial representation of the layer 1 relay, of the functions of repeaters and hops. As you can see, this is one system, say user A, and here is another system, say user B, or station A, station B. They were communicating with each other, and here you have got a repeater in between. So repeater essentially performs bit by bit translation. So it receives bit by bit and regenerates it, transfers bit by bit. So it is operating in the physical layer. So you can see the physical, this is connected to user A as well as it is connected to user B, and the communication is taking place in physical layer. Then a bridge which is essentially a layer 2 relay which links similar or dissimilar LANs. That means with the help of this bridge you can connect to 2 Ethernet LANs or 1 Ethernet, 1 say token ring LAN. So 2 dissimilar or similar LANs can be connected. Here we are not really extending a single LAN. So 2 dissimilar LANs are connected, or 2 similar LANs, 2 Ethernet LANs are connected with the help of a bridge, and it operates in data link layer, as you can see. So this is one side and this is another side which are linked by, so this is one user, this is another user. So this is linked with the help of bridge. As you can see, the frame goes from this side to this side through a bridge, and which operates in 2 layers. So it is designated to perform store and forward frames. So it receives it and then it does some checking, error checking and other thing, then forwards it. So it is protocol independent and transparent to end stations, as we have already mentioned. On the other hand, a router which links, or a layer 3 relay which links dissimilar networks acts on network layer frames not transparent to the end stations. That means it can modify the contents of the frame. It can change the addresses. So it is not really transparent to the end stations. It isolates LAN into subnets to manage and control network traffic. So these routers are very important functions. You will see those I have shown diagram in an internet. They are linked with the help of this kind of devices. These are nothing but routers. Finally, this is the gateway, as I mentioned, which works above the network layer such as application layer. So here you see this gateway which operating in application layer, and two systems are connected through a gateway and the communication is done in this perform. So it goes all down, I mean all the way up to the application layer, and then it comes down and goes to the other side. So this is how the gateway works. Now it is time to give you the review questions. First question is, why do you need internetworking? Second question is, why a repeater is called level 1 relay? Third question is, what is bridge? How it operates in the internetworking scenario? Fourth question is, what limitation of transparent bridge protocol is overcome by the source routing protocol? Fourth question is, what limitations of a bridge are overcome by a router? So these are the 5 questions of this based on this lecture, which will be answered in the next lecture. And here are the answers to the questions of lecture number 32. First question was, distinguish between footprint and dwell time. Answer is, signals from a satellite is normally aimed at a specific area called the footprint. So it covers a small or large area. On the other hand, the amount of time a beam is pointed to a given area is known as dwell time. So that means a satellite can focus its beam for some duration which is of the order of millisecond for transfer of data, for data communication. Then it focuses on some other part. So this is known as the dwell time. Second question was, explain the relationship between the Van Allen belts and the 3 categories of satellites. Answer is Van Allen belts are the two layers of high energy charged particles in the sky. We have seen there are two layers of Van Allen belts, and there are three orbits: lower Leo, Meo and Geo, which are positioned by which are positions above or below these three layers. So, are chosen in such a way that the satellites are not destroyed by the charged particles of the Van Allen belts. So, this is the relationship between the different types of orbits and the Van Allen belts. Question 3 was explain the difference between the iridium and teledesic systems in terms of usage. Answer is Iridium project was started by Motorola in 1990 with the objective of providing worldwide voice and low rate data communication service using handheld devices. On the other hand, teledesic project was started in 1990 by Craig McCaw and Bill Gates with the objective of providing fiber optic like broadband communication. So, here you can see these are the two differences for communication. So, essentially this teledesic system was deployed to provide the service of to provide the internet in the sky. Question 4a was what are the key features that affects the medium access control in satellite communication. We have already discussed in detail. There are 4 features: long round trip propagation delay, which is about 470 millisecond, inherently broadcast media, low privacy and security, then the cost of communication is independent of distance. So, these are the 4 features that you have to take into consideration. Fifth question was what are the possible VSAT configuration. Answer is possible implementation configurations are one way used in broadcast satellite services, for example direct to home service which are used nowadays, satellite television distribution systems. Split two way, in this case VSAT does not require uplink transmit capability, which significantly reduces cost. Two-way are very popular. All the traffic is routed through either master control station or each VSAT has the capability to communicate directly with each other with any other VSATs. So, that is the with this we conclude today's lecture. Next 2 lectures will be on TCP/IP. Thank you.